All right, so let's say you have this half circle, top half circle. A radius 2, centered at the origin. And you're trying to integrate over this domain, this top half circle, this function, y. Now, function z equal to y, the graph of this is z equal to y, and therefore you can think about this plane that's like that. Okay? It's a plane that's like this. So if you think about the three-dimensional shape under that graph over this region, it's more like, let's see, how do I say it? Okay, so it's like potato wedge. Like that, okay. And you take a cylinder and you cut it so that it cuts through the exact half of the bottom circle. That's what you get, okay? And we're trying to find the volume of that. All right, and then we will need to have the graph. See, the way we represent the volume, first, the volume is the double integral, right? The double integral has the meaning of the volume under the surface over the region R. So this is what we are trying to come up with. And since the function is given as just y, let's just say we want dy dx. I chose dy dx because it's easier to represent this top circle using y equal to something. Now, why is that? Well, the equation of a circle is x squared plus y squared equal to 2 squared. And y squared is 2 squared is 4. If I move the x squared to the other side, you get that. If you solve for y, you get plus or minus square root of 4 minus x squared. And see, if you only take the positive one, that means y can only be positive, so you don't get the full circle, but only the positive one. So if you draw the graph of this function, you get the positive, the top circle. Okay. All right, so that's why I chose dy, because if I have dy, I get to place y equal to something and y equal to something, and I already have a good equation for the top circle using y. All right, now let's actually figure out what to place here. So if we were to paint this region going upwards, I'm saying upwards because right here it says dy. Right? Having dy inside, that means it's upwards. And look at where the brushes begin. It begins at this graph, and it ends at that graph, right? What's the equation for this graph? This is y equal to 0. Remember, all the horizontal lines are y equal to a number, and since this is height 0, it's y equal to 0. So y equal to 0 goes here. Now let's think about where it ends. I already found the equation for this. It's this one, right? So that's what I put here. So you start from 0 and you end there. Now, let's look at the x values. What's the minimum x value? -2 and 2. All right? Okay. So now we just compute this and you're done. Now, I forgot your name. What's your name?
Justin.
Justin said, well, why not just do double of 0 to 2, 0 to square root of 4 minus x squared, y dy dx. And this is actually a wonderful idea because, see, this domain is symmetric, right? Not only that, the function here, y, is symmetric. So it's a function which goes up like that. So if you picture the surface, it's symmetric. Therefore, when you calculate the volume of it, you can just calculate this right half and double it. And if you do the calculation, you'll see that because you get to just plug in 0 at some point, this calculation is easier than that one. Okay? So that's a trick that you can use sometimes if you know the graph. Okay? We were able to draw the graph, and that's why we were able to figure out that you can do this. But sometimes, when in doubt, don't do it, but just do the full thing. It's just, yeah, maybe it's risky to do this. But for us, definitely this will be a time saver. So let's do it. If you integrate y by dy, you get 1/2 y squared. Right? And you're plugging in square root of 4 minus x squared and 0 dx 0 to 2. And these go into y, so when this is plugged into y, you get 1/2 square root of 4 minus x squared squared, which will get rid of the square root, right? And then when you plug in 0 into y, it's 0, so you don't subtract anything. You still have to integrate from 0 to 2 with respect to dx. And since 1/2 is a constant multiple, I can pull it outside the integral. And inside the integral, we have 4 minus x squared, because this 2 cancels the square root. So you get 4 minus x squared dx. And then the integral is 4x minus 1/3 x cubed. And you're plugging in 0 and 2. And therefore, when you plug in 2, you get 8. When you plug in 2, that's 8. 8 minus 8/3, that's 16 over 2 divided by 2. That will give you 8 over 3.
You lost the 2 from before, from doubling.
So, oh, thank you. Forgot the 2. Oh, so that 2 just cancels. That's gone. And then, again, when you plug in 2, you get 16 over 3. Okay. So that's the answer.
Question.
Yes.
If you don't take the 1/2 out, could you
Uh-huh.
just multiply it across to make it easier?
Yeah,
to multiply
yeah.
first?
You can also do it that way. You can
Okay.
do 1/2 times 4, which is 2.
Yeah.
You can do that. Yes.
If we on the side, should we just put units cubed as well?
Oh, yeah. I mean, the original question didn't have any units, so you don't have to put any units. Yeah, sometimes I might give you the units in that case if it was given in inches and you put cubic inches. All right, let me do another approach. See, you can represent this integral using polar coordinates too. Right? So in polar coordinates, this is actually much easier to describe. If you try to think about covering this region by outgoing brushes from the center in the radial direction, all the brushes start from 0 and it ends when it hits this circle. What's this length?
2.
The same as the radius, so it's 2, right? So if you use dr, you would have r going from 0 to 2. And then what about theta? Theta will be from 0 to pi. And then, there's one thing that it's easy to miss. What's dA equal to in polar coordinates? R dr d theta. So you need this r. Sometimes if you pay attention too much just to figure out the bounds, you forget that dA translates to r dr d theta. So you need this r. Okay, we still need to come up with a way to represent this y. Y has to be changed into what? R sine theta. See, in polar coordinates, x is r cosine theta, y is r sine theta. And one more thing that appears often enough that you should know is that r squared is equal to x squared plus y squared. Okay? So these get used when you change an integral in rectangular to polar. And since y is same as r sine theta, I have to write that. Okay? All right, let's do the calculation to see if we get the same answer. If they don't match, that means we made a mistake in either one of them. Okay? If I integrate r squared, what do you get?
R
1/3 r cubed. And then you're plugging in 2 and 0. We still have to integrate by theta. When you plug in 2, 2 to the third is 8. So you have 8/3 sine theta. And then you still have to integrate by theta from 0 to pi. Okay, when you integrate sine theta, you get negative cosine. And you have to plug in pi and 0. When you plug in pi, what's cosine pi? Negative 1. Negative 1 times negative 8/3 is positive 8/3, right? When you plug in 0, you get cosine of 0. What's cosine 0? 1. And you get negative 8/3. Okay? And you have to plug this in, plug that in, and you have to subtract. So you have to subtract these two values, which ends up being 8/3 plus 8/3, which is 16/3. It matches with this. Perfect. You got the correct answer.